All right, so remember, your directions for your tests will not tell you exactly that you need to multiply or add or subtract. The directions will just say simplify and state any restrictions. So when you look at the problem, you need to be able to, and I typed up the document. If I haven't sent it out already, I'll send it out again, or I'll send it out. But you need to look at each problem and identify what's going on here. When we just have a fraction and there's no addition or subtraction of another fraction out here, then that means that we just need to simplify the fraction as if it was 2/4. We need to reduce this fraction. So this would then reduce to 1/2. Well, anytime you go to reduce, you need to factor. So we are going to just factor these off to the side. So negative 2x squared plus 32. Well, we know we want the x squared to be positive, so I know my factor, I'm going to be factoring out a negative number. And since both of these are divisible by 2, I'm going to factor out a negative 2. And I'm left with x squared minus 16. All right, now, a lot of people will just want to stop here because you factored something. You did some sort of factoring. But that's not the end. You have to say, can I keep going? And anytime that we have two terms, there's only one way that we can factor so far, and that is a difference of squares. So we look and see, is it a difference? Yes, it is. Can I take the square root of each? Square root of x squared is x. The square root of 16 is 4. So this then tells me that it can factor out our GCF, negative 2. On your test, a lot of you guys kept forgetting to write the GCF. If you forget it in this test, it's going to really, really hurt with losing points because it may be something that you can cancel that you forgot. So then we need to factor and have our GCF. And x squared minus 16. And then it's x plus 4 and x minus 4. And now we need to factor out the denominator. So we'll look at this 3x squared plus 11x minus 4. So we draw our x. 3 times negative 4 is negative 12. The 11 drops, so it's 11. Factors that multiply to 12 and have a difference of 11 are 12 and 1. And since this is positive 11, and since this is negative, we know that they have to be different signs. So one has to be a negative sign because the only way you can multiply and be negative is this one of them was negative. So then since this is positive, the smaller number has to be negative and the larger number has to be positive. And what you guys kept forgetting to do in class is when we use the x method, when it's a number in front of the x squared is 1, you don't really need this part. But once it's something other than 1, you have to get in the habit of writing it. Because since it's a number other than 1, we need to write it in this step in our x method, and then we need to reduce. Well, 12/3 reduces to 4/1. So this factors out to x plus 4. And this factors out to 3x minus 1. Right? Then we look and see, are there any factors that we can cancel? Well, we can cancel the x plus 4 and the x plus 4. And remember, in any of your problems, you will always have to multiply your numerator in. So you can't leave your numerator factored. You can leave your denominator factored, but not your numerator. So this negative 2 will get multiplied into the x, so it's negative 2x. And this negative 2 will get multiplied into the negative 4, so it's plus 8, all over top of 3x minus 1. Right? Then we need to look and say, well, what will make our factor, or what restrictions do we have? So what will make our denominator equal to 0? And that's what x cannot be. So in this factor, if x were to be negative 4, negative 4 plus 4 gives me 0, so it cannot be negative 4. And here, if you can't identify, which I'm going to go through these kind of quickly after this problem since I have the other video that you can watch, but you would set it equal to 0, and whatever value would make this expression equal to 0 is what x can't be. So we add the 1, so we get 3x is equal to 1 divided by 3, so that means x also can't be 1/3. All right, so then for these, whenever you're multiplying or dividing, you factor first. Everything this gets factored. So there's really not any thinking that you need to do. You just factor everything. So for this one, x squared minus 25, well, we know that the square root of x squared is x, and the square root of 25 is 5, so it can factor out to x plus 5 times x minus 5. Right? Then this 2x squared plus 5x minus 12, we would use the x method. 2 times negative 12 is negative 24. The 5 drops. Numbers that multiply to negative 24 and have a difference of 5 are 8 and 3. And since this one's positive, 8 is positive and 3 is negative. We divide each one by 2. This reduces to 4/1. So then this will be factored out to x plus 4 and 2x minus 3. All right? Then we need to move on to the next one. So it's multiplied. So x squared plus 9x plus 20. So we draw our x. 1 times 20 gives me 20. The 9 drops. So factors that multiply to 20 and add up to 9 are 4 and 5. Since this is positive, they're both the same sign. Since this is positive, they're both positive. We put it over top of 1. Now, since this is 1 and not 2 like the problem before. And now this factors out to x plus 4 times x plus 5. And then the last one, we will do x squared minus 3x minus 10. So we draw our x. 1 times negative 10 is negative 10. Negative 3 drops. Numbers that multiply to negative 10 have a difference of 3, so it's 5 and 2. And since this is negative, 5 has to be negative. And it's over top of 1, so it factors out to x minus 5 and x plus 2. All right, now we just need to cancel out any of our like terms. So here we have an x minus 5, here we have an x minus 5, here we have an x plus 4, and here we have an x plus 4. So what we're left with then is x plus 5 times x plus 5 over top of 2x minus 3 times x plus 2. All right, now remember, your numerator, you always have to multiply through. You do not have to multiply your denominator. You can leave that as your factors. So we would have to do x times x, which will then give me x squared, x times 5, which will then give me plus 5x, 5 times x, so we have to FOIL it, which is then going to give me another 5x, and 5 times 5, which is then plus 25. So then all over top of 2x minus 3 over x plus 2. So then our final answer will be x squared plus 10x plus 25 over top of 2x minus 3 times x plus 2. And now we have to identify what x cannot be. So the values that x cannot equal are all of our factors before we cancel anything. So in this factor, x can't be negative 4. In this factor, x can't be 3 over 2. And if you're not sure about that, please watch the other video or send me a message. In this factor, x can't be 5. And in this factor, x can't be negative 2. All right, so this next problem here, this is called a complex fraction because we have fractions within a fraction. And remember, fraction bar is actually saying division. So when we see this being divided, that's what this fraction is telling us, by this down here, we can just rewrite it as a division sign horizontally. So this is what I would want for you to do. So this way it's a little bit easier for you to see. So we just write it off to the side. We just divide it by the bottom fraction. And it's a little bit easier for you because now that's horizontally, you should hopefully know how to do this. It might be a little bit harder when you're looking at it in this form horizontally. So now we can just erase all this, all right, because we just wrote it off to the side. And remember, when we do divide, we need to keep, so we keep our first one. Let me write this in different color. So we keep our first fraction, so it never changes. So it's 2x to the fourth minus 18x squared over top of x squared minus 4x plus 3. Then we change from division to multiplication, and then we flip our second fraction. So it's x squared minus 16 over top of x to the fourth plus 2x cubed minus 8x squared. All right, so now, remember, once we're dividing or multiplying, we need to factor. So we're just going to go through and factor everything. So this 2x to the fourth minus 18x squared, well, 2 can come out of both, and x squared can come out of both. So it's 2x squared. And we're left with x squared minus 9. And hopefully by now, this one is easy for us to factor because we can take the square root of each, x and 3. So it's 2x squared, and then it's x plus 3 times x minus 3. All right, now we need to move on to the next one. So we have x squared minus 4x plus 3. So we can draw our x. 1 times 3 is 3. The negative 4 drops. So numbers that multiply to 3 and add to 4 are 1 and 3. And since this is negative and this one's positive, meaning that they have to be the same sign, they both have to be negative. We divide by the 1. So then it's x minus 1 times x minus 3. Right? Then we need to factor this x squared minus 16. Well, we can take the square root of each. It's x and 4. So it's x plus 4 and x minus 4. And then the last one, x to the fourth plus 2x cubed minus 8x squared. Well, we can take out x squared, and we're left with x squared plus 2x minus 8. So then we need to factor this out. 1 times -8 is -8. The 2 just drops. Numbers that multiply to -8 have a difference of 2, so that would be 4 and 2. And since this is positive, 4 is positive, and the 2 is negative, so we divide each one by 1 because that's the number in front of our x squared. So then this one factors out to x plus 4 times x minus 2. Right? Now we just go ahead and we look to cancel out our factors. So we have an x minus 3 and an x minus 3. We have an x plus 4 and x plus 4. I'm sorry, but I forgot real quick one thing. This x squared needs to be out front. So then this x squared can cancel out with this x squared. Right? And then we're just left with 2 times x plus 3 times x minus 4 all over top of x minus 1 times x minus 2. So now we're going to go ahead and multiply this off to the side. So 2 times x plus 3 times x minus 4. Well, we need to FOIL this out, so it gives me x squared minus 4x plus 3x minus 12. So then this will give me 2 times x squared minus x minus 12. And when we distribute the 2 into all of them, we will get 2x squared minus 2x minus 24. And remember, you never have to multiply the denominator, and you can leave it as its factors. But now we need to say what x cannot be. So it's not only just the answer, but it's everything before we cancel. And also, if you notice, here, this was in our numerator, or denominator, and now it's in our numerator. This was in our numerator, now it's in our denominator. So remember, whenever you divide by a fraction, you need to look at all of your factors, whether if it's a numerator or denominator, and any of them that make it 0, x cannot be. So for this one, x cannot be 1, so x can't be 1. For this one, x can't be 3. For this one, x can't be -4. For this one, x can't be 4. We already said this one here, so we don't have to say it again. For this one, if it's just an x with nothing being added or subtracted, it can't be 0. And then the last one, it can't be 2. All right, so this is your final answer, and these are your restrictions. All right, remember, when you're adding or subtracting, the very first thing you should do is just look straight at your denominators. And if they're the same, then there's nothing you really need to do, but you just add or subtract. But if they're not the same, then we have to factor. You never factor the numerator until the very end. That's the very last thing we do. So if something can be factored in the numerator in the beginning, don't do it. Wait until the end. Otherwise, you're not going to be able to answer this correctly, because you cannot cancel out factors that are opposite of fractions, and you cannot add factors. So we want to make sure we leave them how they are, and then we just factor them at the end. So if we look here, we do not have the same denominators, so we need to factor our denominators out. Well, this x plus 3 can't factor. Well, this x squared minus 9 can factor to x plus 3 and x minus 3. So remember, I said before, if you just have a highlighter, highlight your factor. So here's an x plus 3, there's another x plus 3. Here's an x minus 3. I don't have any x minus 3s on the other one. So then I look. This one has just yellow factor. This one has yellow and pink. So that means this here is missing the pink factor, which is x minus 3. And since we are adding and subtracting, we need to multiply it by x minus 3 over x minus 3. So we will then distribute. So x times x gives me x squared. X times -3 is minus 3x, all over top of x minus 3 times x plus 3, plus -18 over x minus 3 times x plus 3. Now, since our denominators are the same, we can just add. And when we go to add our numerators, there's no like term, so it's just x squared minus 3x minus 18 all over top of x minus 3 times x plus 3. And now we need to factor this numerator out. So then we have 1 times -18 is -18, so then the -3 drops here. And then factors that, or numbers that multiply to 18 have a difference of 3, or 6 and 3, and since this is negative, 6 is negative. We put it over top of 1 since this number here is 1. So then this numerator factors out now as x minus 6 times x plus 3 over top of x minus 3 times x plus 3. So you only factor your numerator at the very end after you actually combine it into one fraction. And now we look to cancel out any like factors. So here we can cancel out the x plus 3, so our final answer is just x minus 6 over top of x minus 3. Right? And then we have to state our restrictions, say what x cannot be. So it's both of our factors before they get canceled, so it can't be 3 or -3. All right, now we're subtracting fractions. Remember, first thing to look is, are our denominators the same? If they're not, then we need to factor. So this factors to x plus 2 times x minus 2. So here I have an x plus 2 and an x plus 2, and here I have an x minus 2. So this side here is missing because we had the pink, it's missing the yellow. So I need to multiply it by x minus 2. Right, so now I need to multiply the numerator, so I'm just going to do it off to the side here. So x plus 4 times x minus 2. So this will then give me x squared minus 2x plus 4x minus 8. So then this will give me x squared minus 16 over top of x plus 2 times x minus 2 minus x squared. This adds to plus 2x minus 8 all over top of x plus 2 times x minus 2. All right, now remember, one of the things that a lot of people will make mistakes on is I was asking you to write this like this. When you combine it, especially when it's subtraction, write your two numerators on one numerator, leaving the second one in parentheses. So you should write it like this. And the reason is you can distribute this negative sign in. So then now it will remind you that you need to actually, that you're subtracting everything properly. So you're left with x squared minus 16 minus x squared minus 2x plus 8. I'm sorry, I just realized this should have been 2x squared this entire time. So when we do x squared minus x squared, this should have been 2x squared minus x squared, so we should have been left with x squared and then minus 2x, and negative 16 plus 8 is minus 8, all over top of x plus 2 times x minus 2. Now this numerator needs to be factored, so we can draw the x. So we do 1 times negative 8 is negative 8. The negative 2 drops. Numbers that multiply to 8 that have a difference of 2 are 4 and 2. Since this is negative, the 4 has to be negative, and since this is a 1, we divide each one by 1. So then this factors out to x minus 4 times x plus 2, all over top of x plus 2 times x minus 2. So then these factors cancel, and we're just left with x minus 4 over x minus 2. And remember, we have to say what x cannot be, so it's this factor and this factor, so it's negative 2 or positive 2. All right, now the difference between this problem and all the others that we did is this is an equation. So whenever we have fractions with an equation, we want to get rid of them. If we didn't have this over here and we only had these fractions, then we can go ahead and just cross multiply. But once you have multiple terms on one side, you need to multiply by your LCM or your LCD, your least common multiple, your least common denominator. So then we write all of our denominators off to the side. Any denominator that we can factor, we can. So a squared minus 1 factors to a plus 1 and a minus 1. And now when we're looking for our least common multiple, especially when we have our variables, each variable or factor, including the variable, needs to be included. So here we have a minus 1, so I need to make sure that's included in my least common multiple. Here we have a plus 1, so I need to make sure that that's included. Now, here we have a plus 1, which we already wrote down. Here we have a minus 1, which we already wrote down. So the least common multiple between, or least common denominator between all of these denominators is a minus 1 times a plus 1. And now we are going to multiply everything by that. Right? Every single term gets multiplied by this. And I showed you in class why that works when we're dealing with fractions, why we're allowed, or how we're allowed to do this. But now we can go ahead and we cancel out any of our now we can cancel out anything that's in our denominator, it's in our numerator. So a minus 1 will cancel with this. So anytime you multiply and divide by the same thing, they cancel. And remember, we're not actually trying to add these two fractions together. That's why we're not multiplying it over top of itself. We're just multiplying each one by the same multiple. And since it's an equal sign, as long as we multiply everything by the same number, or in this case, the same factors, we're not changing the value of anything. We're just rewriting it. And now we're left with 1 times a plus 1, which if we distribute the 1 in, that's just equal to a plus 1. Here, the a plus 1 cancel, and now we're left with plus a minus 1 times 4. So if we distribute this in, that will give me plus 4a minus 4 equal to, and here the a squared minus 1 factors to a minus 1 and a plus 1. So this a minus 1 cancels here, this a plus 1 cancels here, so it cancels out our entire denominator, so we're just left with equal to 7. Now, by doing this, multiplying by our least common multiple, it clears our fractions out. We no longer have a fraction that we need to solve for. And it's much easier to solve for it when it's in this form than when it was in our original. And now we just go ahead and solve this regular basic linear equation. So 4a plus a is 5a. 1 minus 4 is minus 3. Then we will add over the 3. So we have 5a is equal to 10. And then we divide each side by 5. A is then equal to 2. All right, but now we need to make sure we say what a cannot equal. Because remember, if a cannot equal 2, that means we have no solution. It's an extraneous solution. But a can't be 1 or negative 1. And this will be your final answer. All right, that's all I'm going to go through in this video because the last question that we were going to do in the review, I ended up putting the wrong question on there. So we'll cover it in next class for review. But that's it.